So we have seen how to solve linear inequations. We have just looked at the linear inequations till now. Let us move on to higher degree equations, inequations in fact. Like if what happens, how do we deal with second degree variable with an inequation, a third degree variable with an inequation. So to understand how to handle a higher degree inequations, we will look at a method called wavy curve method. We will now discuss wavy curve method to handle inequations of higher degree polynomials with an inequation of obviously. So what is a wavy curve method? This is a very important method. It simplifies to find the interval of x or to solve a higher degree polynomial inequation to find the final interval of x. So it simplifies a lot of tasks. Now let us see how does this wavy curve method work. So let us take a simple example to understand the wavy curve method. Let me consider x plus 1 into x minus 1 into x minus 2, some higher degree polynomial greater than 0. So I have to find the value of x which satisfies this inequality. Okay, so we have three linear parts here, linear factors x plus 1, x minus 1, x minus 2. So x plus 1 into x minus 1 into x minus 2 should be greater than 0. So for what values of x this inequation holds true. So this wavy curve method will help you to understand or help you to determine the values of x where this inequality is true. So let us see how this method is applied, how this method is used to solve for the inequality. First of all, let us mark the roots of this inequation. Let us find the roots of the equation x plus 1, x minus 1, x minus 2. Let us equate this to 0 and find the values of x. The roots of this equation minus 1, 1 and 2. So x plus 1 is equal to 0, the value of x is minus 1. X minus 1 is equal to 0, x is equal to 1. X minus 2 is equal to 0, x is equal to 2. So we are finding the roots of this equation. The same inequation, forget about this inequality, consider this and equate it to 0 to find the roots. Okay, I hope you all understand what the roots means, where this becomes 0. Now let us draw the number line, the x-axis number line, and mark these three roots on the number line. So let me mark first minus 1, the smallest of all the three, then 1 which is towards the right of 1, minus 1 and 2. So I am marking all the three roots on the number line. What after this step? So let us draw perpendicular lines exactly at the roots like this. So minus 1 is this. I am drawing perpendiculars exactly at the roots. These are the perpendicular lines that I am drawing exactly at the roots. Now this entire number line, because of these perpendiculars, are divided into certain regions. Let us call this as region 1, this as region 2, this as region 3 and this as region 4. So after dividing the number line, exactly drawing the perpendiculars at the roots, we have divided the number line into 4 regions. In this case, in this particular question, we have 4 regions. So 1, 2, 3, 4. After we get these regions, we are going to look at the value whether the region is a positive region or a negative region. So we can determine the region's sign, whether a particular region is a positive region or a negative region. How are we going to find that? You can substitute any value from the number line in the given expression. So I will write this as f of x as x plus 1 into x minus 1 into x minus 2. This as a function of x, okay, and I will substitute any value from the number line in place of x except minus 1, 1 and 2. That means you cannot consider x as minus 1 or 1 or 2. What happens if you consider x as minus 1? This is going to be 0. If you consider x as 1, also it is going to be 0. If you consider x as 2, then also it is going to be 0. So apart from these three roots, Consider any value of x, any other value of x. So which is more convenient? You consider anything which is more convenient. Let's consider some 0. Let's consider 0. 0 belongs to the second region. I am considering 0 as a value of x. So I substitute x is equal to 0. F of 0 is equal to, so 0 plus 1, 0 minus 1, 0 minus 2. So this is positive into negative into negative. 0 plus 1 is a positive value, plus 1. 0 minus 1 is a negative value, minus 1. 0 minus 2 is a negative value, minus 2. Okay, so f of 0, I don't want the exact value, I don't want the value of f of 0. I want to know f of 0 is positive or negative. So positive into negative is positive. F of 0 is positive implies 0 belongs to which region? Second region. So if one value, a single value in a region gives you positive output, then all the values in that region will give you the same output. So region 2 will be concluded as positive region. So how did we conclude region 2 as a positive region? We don't have to verify at every single value in the second region. You just have to verify with any single value and any one value, and if that value gives you a positive output, all the values in that region will give you positive output. What about this region? Will you again substitute some other value? For this region, will you substitute one more value to verify whether this region is positive or negative? You don't have to. After you determine the sign of one of the region, the other regions will simply alternate. Will simply alternate means what? If this is positive, this will be negative, this will be positive, and this will be negative. They are all alternate. So this is positive, so the adjacents, both the adjacents of this region would be negative, and this region which is adjacent to negative would become positive. Understood? So we have determined the sign of the region. So we had 4 regions. So remember, we'll just have a quick revision of what we have done here. So we have first found out the roots of this equation, this particular expression. We marked the roots on the number line. We have drawn the perpendicular lines exactly at the roots and divided the entire number line into 4 regions. After we are done with finding all the 4 regions, getting all the 4 regions, we substituted some value of x. It is not necessary that you should only substitute 0. You can substitute any value of x except minus 1, 1 and 2. You can substitute any value of x. You can also substitute 1000. We should find whether the output of that value of x is positive or negative. So here for my convenience I am substituting 0. So when you substitute 0, the final output is a positive output. So I am getting a positive output by substituting x is equal to 0. So 0 belonging to second region giving you a positive output implies every value in this region gives you positive outputs. Now to determine the sign of this region, you don't really have to substitute any value, but even if you substitute, it's okay, you will get the negative sign. We can verify that. For example, I substitute 1.5. 1.5 belongs to the second region. So substitute that. 1.5 plus 1, 1.5 minus 1, 1.5 minus 2. This is a positive value. We don't need the exact value, we only need whether it is positive or negative. 1.5 plus 1 is a positive value. 1.5 minus 1 is also a positive value. 1.5 is greater than 1. And 1.5 minus 1 is a negative value. So positive into negative is negative. Did we get the negative value? So this region is negative. So you substitute any value between 1 and 2 and verify. The output is going to be negative. The same way you substitute any value from this region and verify, you are going to get a positive outcome. For example, I substitute 100. Substitute 100 plus 1 is positive, 100 minus 1 is positive, 100 minus 2 is positive, positive into positive into positive. So positive outcome. So fourth region is positive. But I am not verifying for each region. No, each time. I am not verifying for each region. I am only verifying for a single region. You can verify with any single value of x. I have just verified for x is equal to 0. I got this region as positive, and from this I concluded the other regions. I concluded that this region would be opposite of this. They will be alternating. So positive, negative, positive. This side, since it is positive, this is negative. This is how it is. Now what is the final conclusion of the value of x for this inequality. So x, now you are looking at the inequality, the actual inequality given in the question, greater than 0. So when you say greater than 0, you are talking about positive region. So region 2 and region 4 is the positive region. These are the regions where the function gives you positive outputs. So what is the value of x finally? So x belongs to region 2 and region 4. How are you going to conclude region 2? Region 2 is this interval -1 to 1. So open interval -1 to 1, union 2 to infinity. This goes till infinity. Fourth region extends till infinity. First region extends till -infinity. So second region, union 4. This union indicates you are clubbing two intervals which are not consecutive. So which are apart from each other. So -1 to 1 and 2 to infinity. I have to express this as well as this as a solution. We use a symbol called as union. So x belongs to -1 to 1. Union 2 to infinity is the solution for this inequation, and that is how wavy curve method is helpful. You can look at the entire solution.